Hey everyone, this is the 11 through 1, 11 through 3 review. So here's a box, okay? The box originally was a 6 by 18 rectangle. So think of it as a 6 by 18 rectangle, okay? We're going to cut out these little corners here. So this is your width and this is your length, okay? So I know what's coming up. They're going to want us to do volume and stuff. So we need height, length, and width. So first of all, when you cut these little corners out right here, it was 6. So if you cut out an X length of each one of these, this 6 right here becomes 6 minus 2X. So originally it was 6, but you're cutting out corners of X length. So it's X, 6 minus 2X. Now the length here is the whole box flattened out, but we're going to fold this in half. Okay, we're going to fold it in half. So just cut it in half. So that means the 18 is now, if you cut this in half, the 18 is now 9 and 9. But we're cutting out a corner on each side. We're cutting out a corner. So if you look at the picture, we're cutting out this much right here and this much right here. So this one right here is going to be 9 minus X, and this one's going to be 9 minus X, which the whole thing would be 18 minus 2X, but it's going to be 9 minus X. 9 minus X if you do half of it. So when this box is folded, this is the piece that you want for the length of the box, not the whole thing. This is the whole box opened up, but when you fold it, 9 minus X. So your volume is X, which is your height, times 6 minus 2X, which is your width, times 9 minus X, which is your length. So starting with this problem then, what is a polynomial function that represents the volume of the box in terms of X when it is assembled? That's what we just did. Volume is equal to this. Okay? So before I even punch it in the calculator, what are your zeros? So this would be 0. If you set this one equal to 0, you get X equals 3. So 1, 2, 3. Okay? X equals 3. And then this one, if you set this equal to 0, you would get 9 equals X. So 4, 5, 6, 7, 8, 9. It's cubic. Okay. So it's gonna end up looking something like this. This is what it's gonna end up looking like. So this is representing volume. Volume, 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 volume. Okay, so it says determine the possible domain and range for the construction of the. So what we're gonna do, we're going to graph this. So we're going to go to y equals. We're going to type in x, parentheses, 6 minus 2x, parentheses, parenthesis, 9 minus x. So it should look like that. I'm going to look at my t-table first. So you notice it's 0. I'm going to make this t-table right here. So it's 0, 0, 132, 228, 3, 0. And then once you get to the 4 all the way to 9 is all negatives. So you can't have a negative volume. And then when you start at 9, you get a 0. And then 10 starts back at the positive numbers. Okay? Once you get to this right here, you're never going to need any of these numbers again. Once you get to the negatives. So this is all you need to worry about for your cutouts. Because if you had a cutout of 10, for example, once you get a positive, if you get a 10 cutout, that's bigger than the original 6. So 10 is just too big. 0 to 3, the first 0 to the second 0 is all you need. So in this picture, we don't need any of this or any of this that's over here. We're only going to concentrate on this portion of the graph right there, 0 to 3. So the possible domain is 0 to 3. I would not include 0 or 3, so I wouldn't put a bracket because those mean your volume's 0. Those are the zeros, and you're not going to have a volume of 0. We got domain, need a range. Okay, so range is low to high. So it's 0 to what? Well, according to this graph, I'm not sure. I know according to this picture here, it looks like 32 is the highest, but there's some decimals in between here that we don't know. So what we're going to do is graph this, but before we graph this, we're going to set our window. So what's important to me is that we're going 0 to 3 by 1. The y's. We don't need to go that high because the 32 was the highest number I saw, but it could be a little higher. Maybe go 40. and go by ones. This is all we have to do. So set your window and then graph. So this is the piece I need. So if I want to know what the range is, I need to know what my max is. So we're going to press second trace, max, number 4. My left bound guess is going to be my zeros. 0, enter 3. I'm doing my domain, 0 to 3. Guess. So it's somewhere between 0 and 3. And it says my max is 1.35. I'm going to write that down. And 34.08. Okay. So I wrote that down. This is my max. So that means my range is 0 to 34.8. Now, the range could be actually higher because it's if you think of it just as a cubic graph, it goes on forever, okay, like this. So typically, your range, you would say your range is all real numbers. But it says determine the possible domain and range for the construction of the boxes, not just for a graph, for the boxes. So range means that the volume, range is representing the volume, is anywhere from 0 to 34.08. It's not going higher than that, okay? So we're talking about in terms of the box, not just in terms of a general cubic graph. So 0 to 34.08 is the range. And I would actually put a bracket. Well, it's a repeating decimal. It's an irrational number, but I'm still going to put a bracket there. About 34.08, okay? So now we're going to sketch and label this. So we got 0, 0, 1, 2, 3, 3, 0. This is all I need. I don't need anything else. And I already got my t-table here, 1 and 32. So let's go, since this was 34, let's go by, I don't know. Let's go by, what do you guys think? 3s? 4s? Let's go by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. So we had 1 and 32. We had 2 and 28. We had 3 and 0, and then we also have our max point, which is 1.35 and 34.08. That's kind of an important one, so I'm going to go back right here. If you want other ones, you can always get some decimals in there, but I don't need them. I'm just going to grab this, hit my 1, my max, my 2, and my 3. It's not the greatest graph, but looks something like that. Use a graphing calculator to find the maximum value of the box. What are the dimensions of the box with the maximum volume? What is volume? Okay, so the height. So the height, remember, was x, correct? So x is our max right here, 1.35. So your height is 1.35, and this was in centimeters. So don't forget your centimeters on the test. 1.35 centimeters. Now the width, if you remember, was 6 minus 2x. So we're going to go 6 minus 2 times 1.35. Clear. 6 minus 2 times 1.35, which again, that 1.35 is the x-coordinate of my max. So my width is about 3.3 centimeters. The length, if you remember, was 9 minus x. So that's going to be 9 minus 1.35, 7.65. The maximum volume was the y-coordinate of our max point, so I don't need to do any work for that. 34.08. What do you guys think? Oh, very important. Centimeters cubed. Centimeters cubed. There we go. Page 1's done. Page 2. The company wants the box to have a volume of at least 21. Write an inequality for the volume that satisfies this constraint. So volume. The volume, they want it at least 21. So that means greater than or equal to 21. At least. 21 or greater. So remember, we had x, we had 6 minus 2x, and we had 9 minus x. Wants to be greater than 21. So they just want us to write an inequality. So that one's done. Use a graphing calculator to determine the interval over which the volume of the box is made as at least 21. So there's going to be two answers here, an interval from here to here. What we're going to do is we're going to use our graphing calculator, basically. You have this. You're going to try to figure out where 21 is right here. And we're going to find this point and this point. And whatever the x-coordinate is of this goes here. And whatever the x-coordinate is of this goes here. So we've already got our graph ready. Remember the graph? So we're going to go to y equals, and we're going to put 21 in. as a horizontal line. Now graph. There it is. So you are going to press second trace, intersect 5. So we're going to bring this little spider over here, and we're going to go a little below the line right there. That's left of the line in the curve. Do you guys see that? Press enter. Now when you go right arrow, it's going to be on the line now. So the first one's going to be on the curve, the second one's going to be on the line. You press enter again. So just make sure you're in between them. Press enter again. And your intersection is 0.4921. It should be 21, right? Because you're intersecting with that line. 0.49 is this. So this point right here was 0.4921, but we need the 0.49 part. That's the first interval. So anything cutout wise, anything cut out 0.49 or greater is going to give you a volume of at least 21. It's 21 here, or anything greater than that's going to be greater than 21. So that at least part. So we have to, all this works, this and all this works. When does it stop working? We're going to press trace. We're going to go all the way over here to the other part where it intersects the red line. Spider, spider, spider. Now we want to be a little to the left of where it's intersecting. So this is to the left. So on this side, you're above it. So we're going to press second trace, intersect. My first curve, we are to the left of the intersection. Press enter. Right arrow is now, you're now on the line. Just go over so that you're a little past where they intersect. Press enter. So you're trying to find this point right in between those two. Press enter. And it's 2.3221. 2.32. So this is 2.32 and 21. That's your intervals. Write a polynomial function in standard form with degree of 5 with these zeros. So if negative 3 is a 0, 0 is, and this is 4i, so is negative 4i. So in standard form, so we're f of x equals x. This one represents the 0, by the way. Then you have x minus minus 3, which is x plus 3. Then you have x minus 3. Then you have x minus 4i. And x minus minus negative 4i, which ends up being 4i. So that's all your factors. And then we have to FOIL this. So the first two, I'm going to FOIL these two first. It's x squared minus 9. And then we're going to FOIL these two. So that's x squared minus 16. This is going to be minus 16i squared, which is positive 16. So you get that. And then we're going to FOIL this. This is x to the 4th, 16x to the 2nd, minus 9x to the 2nd, minus 144, which is x to the 4th, plus 7x squared minus 144. Then we have the final x that's out front, and we're going to distribute that. And this is your polynomial function. Lots of foiling. 8. What is the factor form of a 4th degree polynomial with these coefficients? So if you have a negative 3, you should be looking for an x plus 3. So these all have an x plus 3. That doesn't help. A 1, x minus 1. So it's not, wait a minute, x. So it's not this one. We're looking for x minus 1. So it could be any of the other 3. And then 1 plus 5i. So if 1 plus 5i is root, it would look like this. X minus 1 plus 5i, which is x minus 1 minus 5i. They have it written like this. X minus 1 plus 5i. X minus 1 plus 5i. This one has too many things here. X minus 1. So this right here is right there. So remember, if 1 plus 5i is a root, so is 1 minus 5i. So it looks like you have x minus 1 plus 5i and x minus 1 minus 5i. So it's D. You have 0 of 0.5 is the same thing as saying x equals 1/2. So if you multiply both sides by 2, you get this. This is the factor. Oops, sorry guys. 0.5 is 1/2. Multiply both sides by 2. Subtract 1. 2x minus 1 is the factor for 1/2. So if you would have done this, you bump it up, it's 2x minus 1. So it's 2x minus 1 multiplicity of 6. So Pascal's triangles. 1, 6, 15, 20, 15, 6, and 1. That's the row you need. If you can't remember how to get that, you go to y equals. You go 6, then math right here. Probability 3 x. Then you look at the t table, and you'll see it right there. 1, 6, 15, 20, 15, 6, 1. Now, the first term is 2x. So you're going to take 2x to the 6 all the way down to 2x to the 0. So this is 1 times 2x to the 6. 2x to the 5th, 2x to the 4th, 2x to the 3rd, 2x to the 2nd, and 2x to the 1st, and 2x to the 0. And then the next one is 1, 0 to 1 to the 6, so this is just 1. 1 squared is still 1. 1 cubed is still 1. 1 to the 4th is still 1. 1 to the 5th is still 1. 1 to the 6th is still 1. So it doesn't matter about the ones. But the sign is negative, so they're going to alternate. So this is negative, positive, negative, positive, negative, positive. All right, so 2x to the 6. So 2 to the 6 is 64x to the 6. This is 32, 2 to the 5th, 32 times 6. I'll be with you guys in 1 second. 2 to the 5th times, what was that, 6? This is 192 to the 5th plus 2 to the 4th, so you get 15 times 2 to the 4th, 240, and you're decreasing your exponents. 2 cubed is 8 times 20, x to the 3rd. And then 2 squared is 4, 4 times 15 is 60, x to the 2nd. Then this one is 2 times 6, x. And the last one is just 2 to 0. And 1, 2 to 0 is 1. This should be 1. There it is. Alright, I'm going to do the rest of this video later. I'm stopping this right now.